What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
How do you welcome a traveller that never meant to stay? This month, a small ancient comet from another star glides through our lanes, a quiet visitor that refuses to be caught. We call it 3I Atlas, the third interstellar object ever seen.
A new telescope built to track fast-moving space objects in Chile has caught a comet from beyond the solar system moving across the sky.
It won't loop, it won't linger, it will cross our lanes, leave a few clues, and slip back into the long night. For once, though, we are not late. We know when it brushes Mars, we know the hour it bends past the sun, and we know the single evening when it comes as near to Earth as this messenger will ever dare. The story opened at Rio Hurtado, Chile.
On the 1st of July, NASA detected a mysterious object speeding toward Earth, and some actual bona fide experts think it might not be your typical space rock or maybe any kind of rock or a natural phenomenon at all.
The Asteroid Terrestrial Impact Last Alert System survey was sweeping dense starfields where the Milky Way packs every pixel. A faint point crept through that glitter. Software murmured its sums. The team pulled older frames. Zwicky Transient Facility at Palomar had seen it a few nights earlier. Other Atlas telescopes had too. Transiting Exoplanet Survey Satellite had it tucked inside planet hunting images from May and June. Even the still-warming Vera Rubin Observatory caught it in engineering shots. When the orbit finally held still, it wasn't a loop at all, but an open curve. A hyperbolic orbit, a one-pass path not bound to the Sun. The minor planet center stamped the new name, 3I the Third. A small coma appeared. The clock began. What arrives is a comet in the oldest sense, a solid, icy nucleus wrapped in a cloud of dust and gas. Sunlight warms it, ices sublimate, dust lifts and drifts. A tail leans away from the sun and lengthens. The haze hides the core, but Hubble's sharp vision pins a hard ceiling on size, no bigger than about 5.6 kilometers, and likely under a kilometer across, small by planetary measure, big enough to carry news. It moves with the confidence of a long-distance runner. When Atlas first flagged it, 3I Atlas was already pushing around 60 kilometers per second relative to the Sun. By the turn near the fire, it presses into the high 60s. That is galaxy pace. You don't bind something like that with a single pass of light and heat. Because we found it on the way in, we can tell this story forward. First window, Mars. The comet slips past the red planet on the 3rd of October 2025, missing by about 0.19 AU, just under 29 million kilometers, a clean, polite pass. On paper that sounds distant. In practice, it's perfect because Mars hosts our outposts. Teams on the Mars Reconnaissance Orbiter, with its high-resolution imaging science experiment camera, and on Mars' atmosphere and volatile evolution, have been shuffling target windows and power budgets, so their instruments can stare into the dark while Earth's biggest space telescopes avert their gaze. From Mars, the haze is brighter, the geometry kinder. For a few days, that world becomes our balcony. Weeks later comes the turn at the fire. The moment is exact. The room goes quiet when you say it aloud. On the 29th of October 2025 at 11:44 UTC, the comet reaches perihelion, its closest point to the Sun, at about 1.36 AU, 126.42 million miles. That is just inside Mars's track, just outside ours. Hubble and Webb do not watch. Their sun avoidance rules are hard lines meant to keep them alive. The comet neither knows nor cares. It keeps going. In the first days of November, it sweeps wide of Venus at about 0.65 astronomical units, 60.42 million miles, and the sun angles finally start to soften. After conjunction's glare, Hubble returns to ultraviolet work later in November. JWST steps back in December, ready to listen for new lines as different ices wake and others fall quiet. Then the night you can circle in ink, 19th December 2025. That is when 3I Atlas comes nearest to Earth, still a gentle approximately 1.80 astronomical units away, roughly 269 million kilometers. No danger, no searchlight in the sky. Just the closest approach we are granted, sliding into evening. drifting out of Virgo toward Leo and fading, week by week. Months later, on the 16th of March 2026, it dips by Jupiter at approximately 0.36 astronomical units, 33.5 million miles, and thins into the dark between stars. If you try to picture its path, don't imagine a marble circling a bowl. Imagine a skater going the wrong way across a crowded rink, almost in the same plane as everyone else, but against the flow. To our eyes in October, that geometry is a trickster. The comet tucks too close to sunset. It's still there, but we can't see past the sun. That's conjunction. From early October until about the second week of November, our view is washed in daylight. As mid-November opens, it creeps back into pre-dawn, low and thin. December is kinder, evening chances, longer exposures, steady tracking, a soft grey smudge from another star's backyard. What will you actually see? Not a freeway bright beacon. Even at its best, 3I Atlas hovers near magnitude approximately 11 to 12. That's a camera target, not a naked eye show. An 8 to 12-inch backyard telescope will serve you well. The new little smart scopes will too. The trick isn't superhuman eyesight, it's patience. Letting the camera breathe, stacking the light until a shape appears and you realize your frame holds a traveler from elsewhere. And what does that traveler breathe? The Comet rulebook expects green, a glow from dicarbon and its cousins in the coma as sunlight tickles them awake. 3I Atlas is not singing that note, at least not yet. Spectrographs listening in August and September heard something stranger. The coma is dominated by carbon dioxide, roughly 8 parts CO₂ to 1 part water, with carbon monoxide humming along and pinches of carbonyl sulfide and cyanogen in the mix. The usual C2 and C3 bands that paint so many comet photos didn't show in those early looks. The dust itself scattered light the way very cold outer system surfaces do. Strong negative polarization, as if the grains are icy, skinned in dark old organics. Then the metal spoke. In the ultraviolet and blue, nickel lines stood tall while iron stayed quiet. In solar system comets, the two often travel together, freed from similar minerals by similar sunlight. Here the balance is off. One gentle idea is that nickel rides in more volatile compounds, slipping free at lower temperatures, while iron hangs back in tougher grains. Another is simply geometry and grain physics, how dust is shaped, how light threads it, how a faint sun-facing plume seen in July turns our view of the inner haze. None of those ideas ruins the headline. They sharpen it. 3I Atlas was built in a colder kitchen than ours, likely beyond the carbon dioxide frost line of its parent star, where CO₂ turns solid and writes the recipe. And yet, the sky keeps a sense of humor. On the night of 7th September, while a total lunar eclipse turned the moon to ember, careful amateurs posted images that seemed to show the coma's color sliding from faint icy blue toward emerald in just a few hours. The usual culprit, fresh C2, wasn't present in professional spectra around the same time. Was it a filter quirk in a blood-red sky, a processing echo, or a rarer molecule taking a brief turn in the glow? For now, that puzzle sits on the whiteboard with a neat underline. Check again after conjunction. When the comet steps out in November, telescopes will listen. Mystery does not make it magical. It makes it alive. Where did this thing begin? Follow its motion backward, and you find it coming up from the southern sky, out of star-rich lanes near the galaxy's center, opposite the sun's local drift. Its speed and tilt make sense for a disk object rather than a halo wanderer, and its character points to a population that may include the thick disk, older stars, fewer heavy elements, a quieter youth. If that is right, this snowball could be older than our solar system by billions of years. Some teams place its likely age between about 7 and 14 billion. That age isn't a number you hold in your hand. It's a way a thing holds light, icy grains that remember colder suns. The science is a relay. While Hubble and Webb obey their safety lines near the sun, Mars carries the baton for early October. As the glare eases, Hubble returns late November to read the ultraviolet fingerprints. Webb comes back in December to weigh the ices after the turn. All sky spectrometers map the wide CO₂ halo, hundreds of thousands of kilometers across, in the near infrared. Ground telescopes catch the shoulders of the season. The comet does not slow down for any of this. We match its pace in shifts, and the larger story sneaks in at the edges. In 2017, we barely noticed Oumuamua in time to wave. In 2019, 2I Borisov blew past and shed more than light. Now 3I Atlas arrives, and we are ready with calendars and choreography. This isn't luck anymore, it's method. The Vera Rubin Observatory will soon scan the southern sky every few nights with a depth and speed we've never had. Its software will learn from this season, hyperbolic motion flagged early, odd colors tagged fast, and the next messengers will be caught inbound, not on the way out. Engineers sketch rapid response probes that can launch small and quick, some even from Mars, to meet the next visitor before it is gone. Nothing about that is easy. Everything about it is possible. So what does closest to Earth actually mean? It means letting go of fireworks and holding on to truth. On the 19th of December, there will be no green sword above the freeway, no shadow racing across the ground. There will be a soft smudge in a field of stars, faint but steady. And if you stack the light long enough, the smudge will become a shape with a direction. And you will know that for a few minutes, a traveler from an older neighborhood was as near to your street as it will ever be. That is not a disappointment. It is a privilege. We live, the cosmologists like to say, in cosmic evening. The first stars woke long ago. The far dark is unimaginably far ahead. It sounds melancholy until a thing like this appears, older than our worlds, dusted with unfamiliar frost, drifting exactly where our instruments can reach. In the last warm nights of the year, you step outside, the mount hums, the exposure begins, and the universe feels just a shade larger than it did before.